All right, so we have solved absolute value equations. Now we are going to solve absolute value inequalities. And so we're going to start by just talking about what absolute value means again, so that these solutions make sense. And so absolute value always measures the distance from 0. Okay, and so if I say the absolute value of x equals 3, since the distance of x from 0 is 3 units, that could give us two solutions, 3 or negative 3. And so if I graph this, here's 0, here's 3, here's negative 3. Okay, and so both of these are a distance of 3 from 0, and so that's why both of these are solutions to this equation. All right, so I'm going to put these numbers down here. All right, so for this inequality, it says the absolute value of x is greater than 3. That means the distance from 0 is greater than 3. That means a solution to this could be 4, it could be 5, it could be 6. All of these values that are greater than 3 have a distance greater than 3. And so as long as we don't equal 3, we can have any of these numbers bigger. 3.5 is greater than 3 away from 0, all of them. Same with the values over here, negative 4, negative 5, negative 6, all of those negative values that are more negative than 3 are also a distance greater than 3 away. We just can't have anything within this spot. And so the solution to this inequality would be x is less than negative 3 or x greater than positive 3. Okay, the two purple regions I've shaded on my number line would satisfy the fact that we have to have a distance greater than 3. Over here, this is my less than sign. And so this says the distance has to be less than 3 away. That means 2 would work, 1 would work, negative 1 would work, negative 2 would work. And so we can have any number in between negative 3 and positive 3, and all of those answers would have a distance less than 3 away. Okay, and so the solution to this inequality would just be negative 3 to 3. All right, and so we're going to use this idea to solve these equations or these inequalities without using this number line. We're eventually going to put them on the number line, but to do it algebraically, you need to notice one pattern. And so let me get, blue will work. Notice that if we have a greater than sign, we had two answers, and they were separated by an or. Okay, if we have a less than sign, we had one interval, and it was between two numbers. So another way I could write this inequality is to say x is greater than the negative 3 and x is less than 3. Okay, and so anytime you have something that is simultaneously true, you can use the word and. Anytime they can't both be true at the same time, you have to use this word or. You can't be less than negative 3 and greater than positive 3. That's impossible. You can't be both of these at the same time. However, you can be greater than this negative 3 and simultaneously less than 3. And so that's why I'm allowed to use the word and. Or and the word and have very specific meanings in math, and you cannot use them interchangeably. And always means a sandwich. I don't think that's how you spell sandwich. I don't think there's an H. Okay, sandwich, meaning you can sandwich the x between your two inequalities. That's when you see the word and. If you have or, that means two different inequalities, and you can't be in both at the same time. Okay, and so anytime you see a greater than sign with this absolute value, you're going to think greater. Anytime you see this less than inequality, you're going to think less than. That's how I remember. Greater uses an or, less than uses an and. And then you end up writing your final answer as a sandwich. Okay, and less than. Or, and you cannot use a sandwich. No sandwich for ors. Okay, and so I'm going to restart, and we're going to go through some examples on where the or and the and apply.